So to talk about these two concepts, the confidence limit and interval, I'm gonna still use this mole illusion example, the practice as an example. So still we are having these 10 participants as our sample, and the mean for these 10 data points for these 10 participants is 1.46, and the standard deviation for the sample is 0.34. Okay, so first I want to talk about why the point of this confidence limits and interval. So I'm gonna switch to my OneNote, and because I have some I have done some drawing there. Okay, so this is some drawings. I want to illustrate two populations. Okay, so let's say this black circle represents the population in our mole illusion example, which we want to compare our sample with. Okay, so in other words, this population's mean is 1. That's the standard ratio between the two, the horizontal and the zenithal. Okay, so again, this black circle represents the population which we want to compare our sample with. Okay, and this colorful circle represents. Let me talk about this our sample first. So let's say this little small sample, this small circle is our sample, right? This 10 people, and we know the mean for this small sample is 1.46. Okay, and let's say this small sample is coming from a population, and this population has different samples in it. Okay, so again, this colorful big circle represents the population where our sample comes from. It's definitely different from the population we want to compare our sample with. That's two different populations. And by the calculations, we have concluded that these are two different populations. They have two different means. Okay, so the point here for us, we just talk about this confidence limits, and what are these two things, and what's the point here? So before I explain the details of these two things, I want to say the purpose why we want to have these confidence limits or the interval. The purpose here is we want to estimate the mean or the range of mean for this population where our sample comes from. Okay, so for this moment we don't care about this sample. Okay, so we don't care about this population anymore. All we want to do here is we just want to have an estimate about the mean range of this population where our sample comes from. Okay, so let me put down my what I just said here. So this confidence limit and interval is to estimate the mean or the mean range of the population where our sample comes from. Okay? Again, so at this moment, we just completely abandon this population here. We don't care about this population anymore. We want to know more about this population where our sample comes from. So for this population, we have one sample, and then we have the mean of this sample. And we may have also other samples. Probably the other samples have different means with this sample, such as, let's say, this sample, its mean is, let's say, 2.01. Okay, so we may have different samples from this population. Some of them are close with the population's true mean. Some are a little bit off. So here is a question: what is the true mean for this whole population? And this we want to, of course, we cannot have a very accurate estimate of this population's true mean. So what we can do is to set a range for this true population's mean. Okay, so we hope that our true population's mean will be likely to fall into this range. Okay? So we're going to talk about this range. Okay? So back to our slides. So this one sample mean is a point, it's just a kind of a point estimate of the population's parameter, which is the population's mean. Okay? And right now, like I said earlier, we want to set a range where our population's true mean is likely to fall in. Okay? So this range, we call it kind of something interval. So this interval estimate set limits for population's parameters. Okay? So this range will set a limit where our population's true mean is likely to fall in. And right now, I'm going to talk about this confidence interval. So the range we just talked about is actually this confidence interval. Okay? So in other words, this confidence interval is a range of values that we estimate our true population values to lie in. Okay? And this kind of upper and lower limits of this confidence interval, we call it confidence limits. Okay? So the confidence limits are the lower and upper extreme values in the confidence interval. That's basically the lower and upper boundaries of this range. Okay? So I'm gonna kind of do some calculation to help you guys better understand these two concepts. Let's see. Okay, so here again we have this samples mean, and this samples mean only provides 1 point estimate of the population's mean. It could be somewhat accurate. It could be it could be really off. Okay, to have a better estimate of the population's mean, we want to work on this confidence interval because it's a kind of a range. Help us identify kind of this kind of interval that our true population mean is likely to fall in. Okay. To visualize it, let's say this is kind of a distribution, and our population's true mean is likely to fall at any point of this distribution. Okay, so we want to estimate this lower and upper limit of this distribution where our population's true mean is likely to fall in. And we're going to start with our samples mean, which is 1.4063. And we want to kind of go to this lower tail and go to this upper tail, and then set a limit for a range where our population's true mean is likely to fall in. So the next step is we want to find out the value for this lower limit and also this upper limit. Okay, so I put too much information on this slide. It's a little bit kind of overwhelming. But let's kind of work through this slide step by step. So we now have this sample statistics, the mean, the standard deviation of this sample. And we also know this kind of the t-test formulation or the t-score formulation. So we want to use this 95% as our kind of as the standard range. So we checked the t-table and found the critical t-value for this 95% range, positive 2.26 on the right tail and the negative 2.26 on this left tail. Okay, so we plug in this number here, plug in this negative and positive 2.26 here. And then we plug in our sample mean here, minus the mu. Mu is the thing we want to work out, right? We want to find out. And then divided by the sampling error, okay? And we plug in all these numbers into here, okay? And then we're gonna do some algebra, and we kind of move things around a little bit, and then we move this kind of the mu, the population's mean, to the left side of this equation, and then do this kind of computation here. And this gives us two numbers here. Okay, so we have this, the upper limit for our estimate of the population's mu as 1.707. And then we work on this negative 2.26 to work out the lower limit for our population's true mean, which is 1.219. Okay, so these two numbers represent the upper and the lower, this upper and the lower limits for our estimated population's true mean. Okay, so in other words, we can say that we estimate the true population, the population's true mean, where our sample come from, is somewhere is lying somewhere between this upper limit, which is 1.707, and this lower limit, which is 1.219. Okay, so this is kind of a visualization. So let's say this is kind of our sample mean, and based on this sample's mean, we estimate the range of our population's true mean, which is somewhere between 1.219 and 1.77. And this kind of this bracket, right? This range is something we call confidence interval, and this means we have this kind of confidence that 95% of the true mean of the population where our sample comes from, right? That's a colorful population. Remember the drawing. So 95% of the true mean ratio of the Moore illusion would fall in between 1.219 and 1.77. Okay, and this range we call it confidence interval. And these two limits, this upper and the lower limits, represent the confidence limits. Okay, and this is the general expression or equation, a formula how to calculate the lower and upper limits to estimate the population's mean. Okay, so we call it a confidence interval 0.95 equals the sample's mean plus the t-value, because we have two t-values, the positive one and negative one. The positive represents this cutoff t-value on this on the right side of this distribution, and this negative t-value represents the lower critical t-value on the left tail of this distribution, and then multiply by the standard deviation. Multiply by the standard error, which is the standard deviation of our sampling distribution. Okay. So this is kind of the equation how to calculate these confidence limits. Okay. So that's pretty much about this t-test. And in next module, in next video, I'm gonna show you guys really quick about how to do this t-test in our environment. We're gonna do some coding, and then I'm gonna talk about how to interpret the results. So far for this lecture, to summarize this lecture, we talked about when we want to compare a sample with a population's mean, right? We want to see whether this sample is coming from this population or the sample is has a same mean with this population. And in this situation, we have no information about this population's standard deviation, right? So the only information we have about this population is just the mean of the population. So what are we gonna do? We're gonna use our sample's standard deviation to estimate this standard error, okay? And then we're gonna go through the exactly same procedure with the z-test we talked in before the first exam, okay? The same logic, the same procedure, and then we're gonna use this t-table to find out the critical t-value. Okay, so that is the hypothesis testing applied to t-test when we compare a sample's mean with a population's mean when this population's standard deviation is unknown.